So in this presentation, I'll be going over firstly what a decision matrix is, how it works, and how you can create one. I'll then discuss when the appropriate or the optimal time is to use a decision matrix, and I'll give you an example. Then I'll talk about the advantages and limitations of using decision matrices to assist in your decision making. And finally, I'll discuss how you can use decision matrices to assist in designing and combining the subsystems of your robot. So what is a decision matrix? A decision matrix is pretty much just one tool that you can use to easily compare different potential solutions that you have to a problem. So how a decision matrix does this is it breaks these potential solutions down into attributes, which are basically just criteria that you have for what you want the design to be. So for example, pretty much for every part in your robot, you're going to want it to be durable, easy to repair, and reliable. You'll then give each potential solution a score based on each of these attributes. After you have these scores, you'll set up a grid with the x-axis. That will be the potential solutions that you've brainstormed, and the y-axis will be the attributes that you're judging them based on. You'll then fill in the grid with the scores that you've given each potential solution, and then you'll add up each column to get a total score for each potential solution. And then according to your decision matrix, the one with the highest score is the best solution. And this is pretty helpful because it allows you to simplify the complex decision of deciding which of your potential solutions you're going to expand on into a single number. So there are two types of decision matrices that you can use. The first and the more simple option is unweighted decision matrices. This is where all the attributes are considered to be the same importance, and you just take the raw score and add that up to find the final score of each potential solution. However, the more realistic option, and the one that you're probably going to use more, is the weighted decision matrix. The weighted decision matrix is what you'll use when you have attributes that are more important than other attributes. So, for example, making the robot look good wouldn't be as important as making it actually work, and therefore the functional part would receive a higher weight than the appearance part. How weighted decision matrices work is that each attribute is given a weight based on how important it is, and this can be either an integer or a percentage, whichever you find more intuitive, and then just the score for each potential solution is multiplied by the attribute's weight before it is added to the total. As for when you should use a decision matrix, first of all, in order to actually create it, you do need to have a few potential solutions brainstormed. Usually when you're making a decision matrix, you'll have this narrowed down to 3 or 5 potential solutions. Decision matrices should also be used if you have multiple attributes that you want to compare. Decision matrices should also be used when you want to visualize trade-offs between different potential designs. So, for example, a claw that's more durable might not be as reliable, and vice versa. So here I have an example. In this one, we're designing a claw, and the 3 attributes that we're going to consider here are durability, so how easy it is to break, reliability, how often it succeeds in actually doing what's supposed to do, and maneuverability or size, so how easy it is to get around, how often it gets stuck. So as you can see over here, we have 2 possible designs for the claw. Claw 1, it has a durability score of 3, reliability score of 2, and a size of 1. So that doesn't mean it's the smallest, that means that its size is the least optimized. And then for Claw 2, durability, we give it a score of 2 out of 3, reliability 1 out of 3, so it's not very reliable, but it's very maneuverable. However, this is also a weighted decision matrix. So durability, that was the second most important, obviously, and it was given a weight of 30% in comparison to the other two. Reliability, that is going to be the most important part of this claw, and therefore it has a weight of 50%, the largest of the 3. And then for size, that's important, but not as important as the other two, so it only has a weight of 20%. Then, as you can see, these columns were added up to get the total scores, and according to this decision matrix here, Claw 1 is going to be the better option. As for advantages and limitations of using decision matrices, there are a few significant advantages. These are that it helps break down the complex decision of which potential solution you're going to use into numerical values, which are a lot easier to interpret. It's also a very transparent decision-making method, so you can see exactly why the potential solution that you've selected using your decision matrix is, according to this decision matrix, the best one, and it also helps you organize your priorities through weights. So, which attribute of it do you want to be the most important? However, despite this, there are also some limitations to using the decision matrix. The first of these is that weights and scores are still subjective. They're still based on the designer's judgment, so they're not an objective way to determine the best one. It can also be time consuming defining the attributes that you want, the weights, and deciding on scores for each one. Decision matrices also don't need to be used for simpler decisions. They should be reserved for more complex ones in which each potential solution has multiple attributes. And finally, this is the most important one. The decision matrix is not an infallible system. It should be used as a guide to help you organize your thoughts and get you to think more critically about your decision making and which potential solution you want to choose. And it should not do the choosing for you. So moving on to subsystems, the first thing you're going to want to do when choosing designs for your subsystems is to break the robot down into what your original individual subsystems are going to be. So basically define what you're going to have to make. So individual subsystems would be things that only do one task on your robot. So for example, drivetrain, linear slides, arm and claw would all be examples of subsystems. After this, you should fully decide what each subsystem needs to be able to do, and what qualities or attributes it should have, and which of those are the most important. Now that you have those attributes, you can use the decision matrix, or you could also use other tools to individually optimize each subsystem. Once you've optimized each subsystem individually, they need to be integrated into the complete design of your robot. The most important thing to do here is to make sure that all the subsystems will work with each other. So they're not interfering with each other. No part of one subsystem is blocking another one from moving to complete its task. And if you need to, you can iterate the overall design of your subsystems or the whole thing in general, like as a layout, just move the subsystems around. And you can use decision matrices for these too. You could, as one of your attributes for the subsystems, consider compatibility, or use different layouts as the potential solutions, that is, the x-axis on your decision matrix. So overall, the most important things that you should remember about decision matrices are how they work. So they arrange potential solutions and attributes into a grid, and then score them based on how well they perform according to these attributes, and as well as how important each attribute is overall. You should also remember what decision matrices are useful for. They are mostly used to compare different ideas and to prioritize different attributes of your designs. However, most importantly, they should not be treated as a replacement for your own judgment. If your decision matrix says that one solution is the best, but you feel that another solution would be better, then you should go with the one that you think. The decision matrix should be used to help you visualize your decision making process and to guide you, not as a completely infallible tool. All right, thank you.